students, myself Vijay Patani, Assistant Professor at SB Institute of Engineering and Technology. Today, in ODE means ordinary differential equations of higher order, I will teach you this topic, that is non-homogeneous linear ordinary differential equations of higher order with constant coefficients. So let's start. First of all, I will make you understand what is non-homogeneous linear ordinary differential equation of higher order with constant coefficients. A differential equation of the form a0 nth derivative of y with respect to x plus a1 n minus 1 derivative of y with respect to x plus a2 n minus 2 derivative of y with respect to x plus dash 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 plus a n y equals to q of x is called non-homogeneous linear ordinary differential equation of higher order with constant coefficients, where a0, a1, a2 up to an are constants. Q of x is function of x. Capital D equals to d by dx is called differential operator. If in this equation we will replace d by dx by capital D, and if we will take y common, then we have a0 d raised to n plus a1 d raised to n minus 1 plus a2 d raised to n minus 2 plus dash 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 plus an y equals to q of x. Here this bracket is function of d y equals to q of x. So the differential equation of this form, function of dy equals to q of x, that is non-homogeneous linear ordinary differential equations of higher order with constant coefficient. Here the order is n. Now we will see how to solve the differential equation of this form. So that is the name of the topic, general solution of a non-homogeneous linear ordinary differential equation of higher order with constant coefficient. If we have been given a differential equation like this, that is function of dy equals to q of x. Its solution is y equals to cf plus pi. Now what is cf? Cf is complementary function. Now, how we will evaluate CF? To evaluate CF, we will make QX 0. Make QX 0 and solve f of dy equals to 0. From that, you will find CF. Now, what is PI? PI, that is particular integral. PI is also one solution of f of dy equals to q of x. It does not contain arbitrary constants. Where CF contains arbitrary constants. Now Pi is given by this formula. Pi, that is equals to 1 upon f of d q of x. Now, based on q of x, we have different cases to evaluate Pi. Today, we will see case number 1, direct or shortcut method of obtaining particular integral. So today we are going to discuss case number 1 when q of x, that is equals to e raised to ax plus b. Case 1 when q of x is equals to e raised to ax plus b. Now this is the formula of pi, that is 1 over f of d e raised to ax plus b, because q of x is e raised to ax plus b. Now whenever q of x is e raised to ax plus b, to evaluate pi in this case, we will just replace this d by the coefficient of x, that is a in this case. So we will write down 1 upon f of a e raised to ax plus b, but f of a is not equals to 0. If f of a equals to 0, then what to do? Then we will just differentiate f of d, and derivative of f of d will become f dash d, and then after we will replace d by a, and here we are differentiating 1, so we will multiply the result by x raised to 1. So we have x raised to 1 into 1 over, now replacing d by a, so we have f dash a e raised to ax plus b. Here f dash a is, but if f dash a will become 0, then what to do? Then in that case we will differentiate f of d once again and multiply the result by x square and will replace d by a. So it will become like this, that is x square 1 over f double dash a e raised to ax plus b, and f double dash a is not equals to 0. So we will repeat this process till we will get a non-zero value in the denominator. Now we will see some examples based on this topic. This is example number 1. We have to solve this differential equation, that is d square y plus 5dy plus 6y equals to e raised to x. Now taking y common, so we have d square plus 5d plus 6y equals to e raised to x. So this differential equation is of the form f of dy equals to q of x, where q of x in this case is e raised to 1x and f of d is d square plus 5d plus 6. And its solution is given by this formula, that is y equals to cf plus pi. So first of all we will find out cf. So how to find cf? We will make qx 0 to evaluate cf. So we will write down d square plus 5d plus 6y equals to 0. Now this is homogeneous linear ordinary differential equation of order 2. Now to find out complementary function, what we will do, we will just write down f of d equals to 0. We will replace d by m. So we have f of m equals to 0. Now in function of d, that is d square plus 5d plus 6. In this equation we will just replace d by m. So we have m square plus 5m plus 6 equals to 0. Now we will factorize this equation. We will find two numbers such that their product is 6 and their addition is 5, and those two numbers are 2 3 are 6. So we have m square plus 2m plus 3m plus 6. Now taking m common from these two terms and 3 common from these two terms. So taking m common, into bracket we have m plus 2. Now taking 3 common, so into bracket we have m plus 2, that is equals to 0. Now taking m plus 2 common, so we have m plus 2 in one bracket and m plus 3 in another bracket, that is equals to 0. So we have m plus 2 equals to 0 or m plus 3 equals to 0. So from here we have m equals to minus 2 and from here we have m equals to minus 3. So we will write down CF as C1 e raised to minus 2x. This is for m equals to minus 2 plus C2 e raised to minus 3x. This is for m equals to minus 3. Now we will find out pi, and the formula of pi is pi, that is equals to 1 upon f of d q of x. F of d is 1 over d square plus 5d plus 6 and q of x is e raised to 1x. Now we will replace d by 1, that is the coefficient of x is 1. So we will replace d by 1 and we will see whether the denominator is 0 or non-zero. If we replace d by 1, you will get 1 square, 5 into 1 5. So 5 plus 1 6, 6 plus 6 12. So we are getting a non-zero value. So directly we can put the value of a equals to 1. So we have 1 over 12 e raised to 1x. So this is particular integral and the general solution is y equals to cf plus pi, and this is equals to cf is c1 e raised to minus 2x plus C2 e raised to minus 3x plus Pi is 1 over 12 e raised to 1x. So this is the required solution. Now we will solve example number 2. Here the given differential equation is d square y plus 2dy plus 1y equals to e raised to minus 1x. Now first of all we will take y common. So we have d square plus 2d plus 1 y that is equals to e raised to minus 1x, and this equation is of the form function of dy equals to q of x, where q of x is e raised to minus 1x and f of d is d square plus 2d plus 1, and its solution is y equals to cf plus pi. So first of all we will find out cf. To find CF, we will make Q of x 0. It means we will solve the differential equation d square plus 2d plus 1y equals to 0. Now to solve this differential equation, we will write down f of d equals to 0. We will replace d by m. So we have f of m equals to 0. So the equation is m square plus 2m plus 1 equals to 0. Now we will split the middle term, that is 2m. We will find out two numbers such that their product is 1 and their addition is 2. So we have 1 1 ja 1 and 1 plus 1 is 2. So m square, we will split 2m as 1m plus 1m plus 1 equals to 0. Now we will take m common from these two terms. So into bracket we have m plus 1 plus, now taking 1 common from these two terms. So into bracket we have m plus 1 that is equals to 0. Now taking common m plus 1. So we will be having m plus 1 in one bracket, and in second bracket we have m plus 1 that is equals to 0. So we have two factors, m plus 1 equals to 0 or m plus 1 equals to 0. So we have two repeated values of m, that is minus 1 minus 1. So in this case, what is CF? That is C1 e raised to minus 1x plus C2, where minus 1 is repeated, so we will multiply it by x. So we have C2 x e raised to minus 1x. This is the CF. Now we will find out Pi, and the formula of Pi, that is equals to 1 upon f of d q of x. This is equals to 1 over, here f of d is d square plus 2d plus 1 and q of x is e raised to minus 1x. Here the coefficient of x is minus 1, and if you replace d by minus 1, you will get minus 1 square, that is 1, and 1 plus 1 is 2, and if you replace d by minus 1 over here, you will get minus 2, and minus 2 plus 2 is 0. So we cannot directly put down the value of d equals to minus 1 in this case. So for that purpose, what we will do, we will just multiply the result by x, and then after we will differentiate this f of d with respect to d. Now derivative of d square, that is 2d plus 2 will be as it is, and derivative of d is 1, and derivative of this constant value is 0, and e raised to minus 1x will be as it is. Now we will replace d by minus 1. If you replace d by minus 1 over here, you will get minus 2 plus 2. And minus 2 plus 2 is 0. So we cannot directly put down the value of d equals to minus 1. So again we will multiply the result by x, but already we have x over here. So we will write down x square, and then after we will differentiate 2d plus 2 with respect to d. So 2 will be as it is, and derivative of d with respect to d is 1, and if you multiply 1 by 2 you will get 2, and the derivative of 2, that is 0, as this is a constant value, and e raised to minus 1x will be as it is. Now as you can see in the denominator there is no function of d, so this is the final pi. At last we will write down the general solution, that is y equals to CF plus PI, and CF is C1 e raised to minus 2x plus C2 x e raised to minus 2x plus Pi is x squared by 2 e raised to minus 1x. So this is the general solution of the given differential equation. Example number 3, solve d cube plus 8y equals to hyperbolic cos 2x. Here the given differential equation is of the form function of dy equals to q of x. If we will compare the given differential equation with f of dy equals to q of x, we have f of d equals to dq plus 8 and q of x, that is equals to hyperbolic cos 2x, and its solution is given by the formula y equals to CF plus PI, where CF is complementary function and PI is particular integral. So first of all we will find out CF. To find CF we will write down f of d equals to 0. Now we will replace d by m, so we have f of m equals to 0. Now to find f of m, we will replace d by m in f of d. So replacing d by m, we have m cube plus 8 equals to 0. Now to factorize this equation, we will use this formula, a cube plus b cube, that is equals to a plus b in one bracket, a square minus ab plus b square in second bracket. So here we have m cube plus 8 is 2 cube, that is equals to 0. So in one bracket we have m plus 2. In second bracket we have m square minus 2m plus 2 square is 4, that is equals to 0. So we have m plus 2 equals to 0, m square minus 2m plus 4 equals to 0. So from m plus 2 equals to 0 we have m equals to minus 2. Now we will solve this equation using delta method. So we have m equals to minus b plus minus square root of b square minus 4ac upon 2a. So this is equals to minus, value of b is minus 2, so minus minus plus 2 plus minus square root of b square minus 2 square is 4 minus value of a is 1 and c is 4, so 4 4 ja 16 and divided by 2, value of a is 1, 2 1 ja 2. So this is equals to 2 plus minus 4 minus 16, that is minus 12, and minus 12, that is 12 into minus 1, and minus 1 is I square. So square root of 12 I square, that is 2 root 3 I divided by 2. Now dividing the numerator by 2, we have 1 plus minus root 3 I. We have m equals to minus 2 or m equals to 1 plus minus root 3i. Now based on these values of m, we have CF, that is equals to C1 e raised to minus 2x. This is for m equals to minus 2. Now for m equals to 1 plus minus root 3i, we have C2 e raised to 1x cos root 3x plus C2 e raised to 1x sin root 3x. So this is required CF. Now we will find out Pi, and Pi equals to 1 upon f of d q of x. So this is equals to 1 upon f of d is dq plus 8 and q of x is hyperbolic cos 2x. So this is equals to 1 upon dq plus 8. Hyperbolic cos 2x is e raised to 2x plus e raised to minus 2x divided by 2. Just remember this formula. Now we will keep 1 by 2 constant value outside, and we will apply 1 by d cube plus 8 operator on e raised to 2x as well as on e raised to minus 2x. So we have 1 upon d cube plus 8 e raised to 2x plus 1 upon d cube plus 8 e raised to minus 2x. Now as this is case number 1, we will replace d by a. Here the value of a is 2, so 2 cube is 8, 8 plus 8 is 16, so this one will become 1 upon 16 e raised to 2x. But here if you will replace d by minus 2, you will get minus 2 raised to 3, that is minus 8 plus 8, and that is 0. So we cannot put the value of minus 2 in place of d directly. So here what we will do, we will multiply the result by x and we will differentiate d cube plus 8. So this is equals to 1 upon 2, 1 upon 16 e raised to 2x plus multiplying numerator by x, 1 upon, now derivative of d cube plus 8, derivative of d cube, that is 3d square, and 8 is a constant value, its derivative is 0, and here we have e raised to minus 2x. Now this is equals to 1 upon 2, 1 upon 16 e raised to 2x plus x by 3. Now replacing d by minus 2, so we have minus 2 square, that is 4 e raised to minus 2x. Now we will take 4 common from the denominator and we will multiply this 2 by 4. So we have 1 upon 8 e raised to 2x by 4 plus x e raised to minus 2x by 3. So this is the required Pi. At last the general solution is y equals to Cf plus Pi, and Cf is C1 e raised to minus 2x plus C2 e raised to 1x cos root 3x, C3 e raised to 1x sin root 3x plus Pi is 1 upon 8 into bracket e raised to 2x by 4 plus x e raised to minus 2x by 3. So this is the required general solution of the given differential equation, that is d cube plus 8y equals to hyperbolic cos 2x. So in today's lecture we have seen how to find out Pi when q of x is e raised to ax plus b, and we have gone through 3 examples based on this topic. Thank you for watching this video.